now consider case 3. So in order to find the strain energy in a body which is subjected to an impact load. So impact load is actually the suddenly applied load, but the load is dropped from a certain height. So here consider a vertical rod which is fixed at one end and the other end has a collar, and this is the load. And consider this portion, that is top of the collar. From the top of the collar, this load is dropped from a height h. Okay, from this to this, the height from which the load is dropped to the collar is h. So that becomes an impact load when the suddenly applied load is dropped from a height small h. And the length of the rod is like from top of the collar to this vertical portion, fixed portion, is capital L. Now when the load falls on this collar, this will suffer an extension, that is from top of the collar to the top, after which the load has fallen on that collar. The position of collar becomes this. Okay, so from the initial top position of collar to the final top position of the collar, that is extension of collar, is delta L. Okay, now the work done is equal to force into displacement. Load is P, which is the impact load. This is the impact load, P into, here the displacement becomes H plus delta L. Okay, H plus delta L becomes the displacement. Force from the initial position of load, suppose this will take lower point, this is the initial position. After the column has load has dropped on the collar's final position will be here. So on the top the load stands. So from initial bottom position of load is this, then final bottom position of load will be this. So from this to this, the distance is h plus delta L. So work done becomes P into h plus delta L. Now strain energy, which we saw before, was sigma square. This is the maximum strain energy, sigma square by 2E into volume. Okay, when we equate this, that is, this is equal to work done, we'll get the final stress, that is the maximum stress due to impact load, becomes P by A into 1 plus root of 1 plus 2H by PL by A. P by A into 1 plus root of 1 plus 2H by PL by A. So this is the maximum stress due to the impact load. Now suppose the delta L is negligible and it is 0, then work done becomes P into H, which is equal to strain energy is equal to sigma square by 2E into V, and when we equate this we will get what? P into H is equal to sigma square by 2E into V, and we can find the stress if delta L is negligible. Okay, so this is the stress due to impact load. Okay, now U stored in a body due to shear stress. So just I'll write the final formula. Earlier, due to gradually applied load, we have seen the strain energy is equal to sigma square by 2E into V. Now the strain energy in a body due to shear stress becomes U is equal to, in place of sigma we are writing tau, which is shear stress, tau square by 2E. Now here for shear It is modulus of rigidity. In place of V, we are writing modulus of rigidity into volume. So, hope you understood today's video. Thank you.